By the way, on the exam, if I say solve a system equation using Gauss-Jordan elimination, you use matrix. If I don't say Gauss-Jordan, you can use anything you like. All right, Gauss-Jordan, so matrix. 1, -2, 1, 2, -4, 2. That's my diagonal. So everything below diagonal must be 0. I need to change that 2 into 0. What do I do? So write it neatly. So -2 R1 add to R2 give me new R2. The first row stayed the same. 0. -2 times -2 is +4. Add to -4 is 0. And guess what? The last one, what do you think? Also 0, right? -2 times 1, -2 add to 2, 0. What does that mean? If I plug it back, if I plug this back into, if I plug xy back, the second equation is what? Is 0 equals 0, right? Because 0x plus 0y is still 0, and the right hand side is 0. Is this true? Is 0 always equal 0? Yes, always true. Always true. That means this system has infinite many solutions. Can I just pick x and y and plug in, and that will be my solution? No, right? It doesn't mean that you can randomly pick any two numbers and that'll be your x and y. It have a little, you need a bit more TLC. Do you guys remember the parameter t that I used? So I'm gonna solve for x here. If you want to solve for y, it's okay. Up to you. I just don't like fraction. If I solve for y, I like fraction. I don't like it. So I just solve for x. Let y equal. Remember that. Let y equal t. Then x equal what? 2t plus 1. So the solution is in order pair, which is 2t plus 1 comma t. That is your general solution. If I ask you a particular solution, can you do it? If I ask you, give me a particular solution. Give me one. What is it? Say find a particular solution. Everybody have different numbers in mind, right? Gary, give me a number for t. Any number you like. Pick your favorite. 5. T. Gary say, I want to let t equal 5. Then what is 2t plus 1? So what is your particular solution here? In XY order? Yeah, 11 comma 5, right? So that's Gary's particular solution. Somebody else can pick something out. I pick 0, easy. If y 0, then something is x is 1. Somebody else picks something 1 or 2. Doesn't matter, right? I just need a particular solution. Can you do something like this on the exam? I think you think it's a fair question. Huh? Yeah, this is the general solution. This is just one of the solutions. One of the many. If I say solve a system using Gauss-Jordan elimination and give me a particular solution, I think I kind of give it away in my answer. What kind of system equation will have particular solution? The one that has infinitely many solutions, right? So if I say that, I kind of give you the answer. You just have to show me how you come to it. I think it's a good question on exam. Unless you want to do the long one. All right. let's try this one. Why don't you guys try this one using Gauss-Jordan elimination? I'll walk around, see how you do.
I won't split the first question. And then we can't help us do that. You did get through that, like. Oh, wait. I forgot to do that.
Anybody have a, so we know that it's an infinite dimensional solution. The last row should be all 0. Is anyone all 0 in the last row?
I actually. Yesterday it was 7:30.
Yeah, I know. So much sleep the night before. I already made it too. I'm on those. Oh wait, no. So for example, you're gonna use
Right, so. Straight.
So, oh, you don't like that. Yes, yes. Very good.
So, but is this not supposed to be negative one?
No, so,
I thought it was-
it's generally-
Yeah.
That's good news.
Zero. Okay.
You're on the right track. Hey. Oh, that I like I do. Yeah, I'm working. Yeah. Where's just that 11? 7. -7. Very good. More people got the idea, which I'm happy. One, two, -3. You probably get the arithmetic somewhere. 3, -1, -2. 1, 2, 3, -5, -3. All right. So identify your diagonal. That one. And then everything below it, there must be 0, right? So let's take care of that one first, 3. So what do I do? What do I multiply the row 1 by? Yeah, -3 R1, add to R2, that's give me new R2. Rewrite the first row so I don't forget. So 0, right? -3 times 2 is -6, plus -1 is -7. A lot of people get this step. -2 times, I'm sorry, -3 times -3 is +9, and -2 is +7. And -2 times I'm sorry, I keep saying -2. -3 times -2 is +6, and 1 is 7. A lot of people had this, which is good. What's next? This one's next, right? That one's next. So multiply the first row by, still using the first row. So -2 R1, add 2 R3, that's giving me news R3. So that must be 0. -2 times 2 is -4, plus 3 is -1. -2 times -3 is +6. Where was that? Oh, God, I am. Oh, I'm ready. Okay. -2 times -3 is +6. After -5 is -1. And -2 times -2 is +4, as -3 is 1. I see people get that a lot. What's next? This one needs to be 0, right? What do I do? Can I flip row? Can I flip? Oh, it should be, yeah, it should be positive, right? Okay, yeah. So sorry, yes, sorry. Yeah, yeah. Oh, no, hang on. Oh, negative, okay. That's part I was tripping at, wasn't I? Thank you very much. Thank you very much. All right, the two things you can do, either, if you want, you can flip R2 with R3. That's okay, right? You can interchange row, right? You can change anything. The zero is still there, so we're good. Or the other way you can do is you can divide the second row by 7, right? Or -7 per se, because you want to be opposite side. Right? So which one you want to do? You want to interchange row, or you want to divide by -7? All right, 7. Up to you. It's the same thing. All right, so let's divide it by -7. So what I'm going to do is -1/7 times R2 add to R3. Skip me and use R3. So basically, this is what I do. I multiply the whole thing on the row 2 by -1/7. So this becomes what? +1, -1, -1. And then you add down, +1 plus -1 is 0. -1 plus 1 is 0. -1 plus 1 is 0. So all 0. Rewrite that. Maybe we should have flipped row. Well, it doesn't matter. 0, 0, 0, 0. So that's implied, the third row implied infinitely many solutions. And what you do next, you back substitute 1x, let's just say x here, plus 2y minus 3z equal -2, -7y plus 7z equals 7. Can I simplify this one just to make it easy? Yeah, by 7. So x plus 2y, let's rewrite this. And then -y, or divided by -7, how's that? So I don't have a -y. Positive y minus z equal -1. All right, what do I do next? I need to solve for x, y, z, and it's infinitely many solution. Remember the t thing? So let t equal, let t equal y. Solve for, I'm sorry, let t equal z. And nothing wrong with you let t equal y, doesn't matter, but I think it's just nicer. Let t equals, let z equal t, how's that? Then y minus z equal -1 becomes y minus t equal -1. You solve for y equals t minus 1. Do you have any question before I finish? Please ask. It's abstract. All right. How do I solve for x? Yeah, plug into that one. Right? X plus 2y minus 3z equal -2. X plus 2 times y. Y is t minus 1. Everything has to be in terms of t. Minus 3z, which is minus t equal -2. X plus 2t minus 2 minus 3t equal -2. 2t minus 3t, that's -t. Add 2 both sides, the -2 cancel. So x equal t. Final solution in x, y, z. So t minus 1 and t again. The reason I'm doing this because in any textbook that you read, as long as the infinite many solution, they're gonna parameterize it. And they have good reason for it, especially when you go to linear algebra, you see why. Or vector and matrix C. So might as well just get used to it now. Is there any questions? The process is the same, right? Just a little extra step here for infinitely many solution. All right, this will be your favorite, no solution. So that one's a long one. This one will be the short one. Okay. Let's do this together. Or maybe you want to try it first. I'll give you a head start. Try it first. If you have something weird at the end, that's okay. My diagonal. They do that right. Yeah.
always touch it.
Oh,
Yeah.
yeah, we're doing the same row.
The-
So the last line says 0 equals 1.
the-
Oh, yeah. That would say you like, sure.
Yeah.
So we did. All right, if you got the right answer, give yourself 2 bonus check mark. The left hand side always 0, and the right hand side be something else. Therefore, no solution. I'm gonna need to eliminate 3, so multiply the first row by -3. Ooh. All right, you guys gonna aid the quiz? The quiz will be purely matrix. Only one problem. 3 by 3, that's it. Like this, kind of like this. But I mean, not no solution. I'm not saying it could be no solution, infinite limit solution, or one solution, but like this, right? Like this. Rewrite the first row, 1, 1, 1, 1, 0. -3 times 1 is -3 minus 1, -4. -3 minus 1, -4 again, -3, and then 4 is +1. And then I need to eliminate this one. So I need to multiply the first row by -1, R1, add to R3. 0. -1, 5 is +4. -1, 5, +4 again. -1, -1, -2. And then eliminate the 4. What do I do? Yeah, just add, right? Basically multiply second row by 1, right? And add, or just add. So R2 as R3, give me use R3. 1, 1, 1, 1, 0, -4, -4, 1. And then the last one, I got 0, 0, 0, -1. I'm gonna rewrite it just for the formal of it. X plus y plus z equal 1. -4y minus 4z equal 1. 0 equal -1. Is this true? No, false, right? So done, you're done. Say no solution, nothing you can do. What does that mean, no solution? Geometrically, what does that mean? Yeah, they're parallel, all 3 planes. By the way, this plane is not line because there's three variables. All 3 planes are parallel, kind of like this. Like that. They're parallel, right? They never touch each other, so no solution. Infinitely many solution mean looking like this. Right? Say, like the pages, we kind of cut in the middle. All right, 2 more and then we'll be done. 2 more and we'll be done. System with more variables than equation. That means I'm giving you more letters and I'm giving you more rows. I have 4 variables here, but I only have 3 rows. So what does it turn out? See what happened to it. Let's solve it to see what happened. 1, 2, -3, 1, -2. Oh, you know what? Let me check my calculator.
I found this on the web.
It froze earlier. See, it's still froze. Still freeze. Sorry. I was gonna show you how the infinitely many solution look like. Still freeze. Three, -1, -2, -4, 1, 2, 3, -5, 1, -3. What is my diagonal? I'll ask you. Here. No. Let me ask you if it's true or false. Is it right? Is it right? Is it right or wrong? The 1 is included. Is it right or wrong? Wrong, right? Yeah, your diagonal is just up to the -5. That's it. Remember, you're missing an equation. You're missing an equation. So the whatever underneath it has to be 0. Since you guys so pro at this, I'm gonna do a shortcut. What do I multiply the first row by to get the to get 0 in there? -3, right? So I'll do like this. Maybe I'll do like this. -3. Row 1 and add to row 2. 0. -3 times 2 is -6. -7. Add -1, -7. -3 times -3 is +9. Add -2 is +7. Feel a little deja vu. Look like. And -3 times 1 is -3. Add to -4 is -7. -3 times -2 is +6. S1 is 7. I need to eliminate 2. What do I do? Multiply the first row by, yeah, -2 now, right? I'm just doing fast. I don't write it out. 0. -2 times 2 is not -4. Add 3 is -1. -2 times -3 is +6. Add to -5 is is 1. And -2 times 1 is -2. Plus 1 is -1. -2 times -2 is +4. Add to -3 is -1. Similar to the one that we did earlier, kind of. I need to eliminate this. What do I do? Divide the, yeah. Yeah, let's do that. And then add to the third row, right? 1, 2, -3, 1, -2, 0, -7, 7, -7, 7, 0. Is a 0 everywhere? Yeah, 0 everywhere. It's gonna be a +1 here, -1 here, +1 here, +1 here.
I think it's supposed to be +1.
Yeah, +1, right? Yeah. +4. Thank you. So this imply, the last line imply infinitely many solution. Plus 2. Now what do? We don't stop here. We rewrite it as with x, y, z, right? So x plus 2y minus 3z plus w plus u again equal -2, -7y plus 7z minus 7w equals 7. Can I reduce the second row, second equation? Yeah. X plus 2y minus 3z plus w equal -2. I'm gonna divide both sides by -7. So I can have positive y. Minus z plus w equal -1. Now, let me remind you the free variable here. Up here, maybe I'll go all the way up here. Up here, I say y is my free variable. You can let y equal anything. Right? In this case, we pick y is for t. You don't want letter t, you can say y for s. Doesn't matter. But the thing is that I know that y is a free variable. It can be anything. However, x is depend on what? X depend on y. So this is not free variable. This is. Go back to the problem we have. This one have more than one free variables. So you're gonna let w equal No, just a letter. To T, right? That's T. No, that's a particular solution. 2 is not wrong, but it's a particular solution. Yeah. Oh, I want the general solution. Yeah. So let W equal. But you got it right. You're right. You're right both times actually. Let W equal T. Then what? The thing is I got stuck with Z. So what do? Let Z equal something, right? It's another free variable. So I'm gonna let Z equal say U. You're gonna pick letter S, you can, doesn't matter.
Can't be the same, right?
Can't be the same. We assume they're different. I don't know that it's the same or not, but I always assume they're different. All right, so what's Y equal? If W is T, Z is U, then Y equal. Minus U plus T equal -1. And then you solve for Y. U minus T minus 1. Okay. Does my U look funny? U. What about X? Yeah, plug it back in. X plus 2Y. Y is U minus T minus 1. Minus 3Z, which is minus 3U. Plus W, which is plus T equal -2. Combine like term. X minus U minus T minus 2 equal -2. Add to both sides, X equal U T. So here we have two free variables. We have another one is called the U. Your final solution will be U plus T will be your X component. Your Y component is U minus T minus 1. Your Z component is U. T component, I'm sorry, W component is T. The bottom line here is you know how to solve this. So it's not what I'm focusing on. The bottom line here is that if I give you more letters than rows, what kind of solution do you have? Infinitely many solutions. It's true for any case. If you have more letters than rows, then it's always infinitely many solutions. What's the point? Yes. Uh-huh. Well, but you have to come up with a solution. So you have to solve it somehow, right? Yeah. But it just show you that it's infinite many solutions. So you just kind of narrow it down a little bit. I told you on the quiz it's gonna be like 5.2, the one in 5. Yeah. It's kind of like D, but yeah. All right, this one. So this one I call it is the Y one because it's wide but it's short. And it had infinitely many solution. This one I call the skinny one because it's long. I have more equations than letters. So only 2 variables here, x, y, but I have 3 equations. Let's see what happened. What do you think? Make a guess. What do you think? Yeah, what's the answer? What do you think? They look opposite. So opposite of infinitely many solution will be no solution, right? No solution. All right. Why don't you guys try this one? What is my diagonal? Yeah. Just this, right? And I stop. Right? Because if I move on, I'm gonna go over to the other line, which I don't want. The 1 and the 4. That's below the one.
Oh.
If you want, you can do 3 with C, which is 1 and the 4 must gone. I don't have office hours today because I'm helping a colleague cover her class. If you have questions, make an appointment with me, or you go to Lexi. So maybe the 3 as well. Maybe you do the 3 as well. But that's also below. Right. We'll see. We'll see. I'm not sure.
I couldn't find it.
Oh. But yes. Oh, yeah.
You just ignore it. I think she's, oh my God. What? Wait. Wait. How did you do that? I'm sorry. How the hell? What is this? You get full credit on their quiz. What is this?
First one by negative. First one by -1.
Yeah. Okay. Yeah. No, we did that.
By -4.
We did that too. How do you read the negative one? That's how it's going. I was saying. Yeah, it has to be 15. Let's see. Oh, we can't do it after. Because if there's no solution, I can show you why.
You guys got it? Huh? No solution?
Yeah, but I think it's really impacted that's what it is.
Negative 5?
No, that
3?
makes sense.
Oh, okay. Let's see. Yeah, let me. Let's see. So 0, right? -1, so -2, -3, -4, so it'll be -4 here. What about the 4? Multiply the first one by -4. So 0, negative 4 times 2 is -8 plus, so -5, -16, and then 12 is -4. Oh, okay, and then yeah, use this fraction, and then multiply the second row by what? Yes, so something with, we need positive 5 at the end, right? So it should be, yeah, -5/3, right? -5/3. So -5/3, or 2 add to R3. Rewrite the first two line. 0, 0. And then what that one equal? What this? So say -5/3 times -4 add to 4. So positive 20/3 plus 12/3. So what is that? 32/3. Right, 32/3. Is 0 equal 32/3?
Why can't I multiply -3 by 5 and then -5 by 3?
Oh, you can do that. Yes, you can do that. Just like the regular method. Yes, you can do that.
I just got -3 to 2.
And then you add.
Alright.
You can do that. Yeah. So the bottom line is 0, it is not equal to 32/3. Or you know, let it be equal, and then we say not. All right, let me tell you, I claim that I can stop it right here. One little thing, I'll let you go. I say that I can stop it right here. As soon as I got here, I stop. And I can say no solution right away. Why? Oh, what did I do? I didn't remember. So what number there? What you got? Oh, okay, doesn't matter. Some number, right? Some number. But thank you. Is it 8/3? Is it 8/3? Okay, some number. All right, something. 8/3. 8/3. I'll just take your word for it. But it's not important.
I say that I can stop it right here. I don't have to do this next step. Why?
Write out. What happened when you write out? Yeah, it doesn't make any sense, right? You have negative 3y equal negative 4, and then negative 5y also equal negative 4. This makes no sense, right? So you can stop it right there if you want. Right? Just tell me that it's not possible, and then you say no solution. So you see the skinny case where I give you more equation than variable, you have no solution. But if the other way around, if I give you more variable than equation, is infinite solution, right? The quiz is going to be on 5.2 exclusively, just 5.2. That's it. Have a good one. I'll see you next time. See you. See you, Gary. See you. Bye. Bye, Jacob.